So we had 2 talks about MCP, and I thought we can't really have the talks about MCP anymore without having a talk about A2A. But first, maybe a little bit about where you are right now. You're in our office of ML6. It's not the only office. There's actually also an office in Ghent and in Berlin. And you might have seen some balloons around, and you might have seen the 100 there. It's not that we're 100 years old. If an AI company is 100 years old, they would be billionaires right now. So sadly, we're not that. No, it's we recently hired our 100th employee. So that was a great accomplishment for us. We're doing machine learning consultancy. So we do that in different subjects like energy. We do it in the HR field, customer experience. So that's a little bit about ML6. But without further ado, let's get into the newer kid on the block. So that's Agent2Agent. And probably someone said somewhere that this is the greatest invention since MCP. They might be right, they might not be. Let's dive into that this presentation. So to zoom out first, looking at the bigger picture, we're seeing a transformation. So we started at the LLMs. First, these were just the token predictors. We could do some fun stuff with this, but it really came to the orientation when we could chat with those. And now we are in the age where we are connecting those chatbots to tools. So we moved from the foundation models to the train to chat, and now we're in the agentic workflows. But in the future, we are now kind of seeing some more autonomous agents, and then we're also moving to the multi-agent systems. So zooming on the agentic workflows, of course, we're seeing all these MCP examples now. And with these agentic workflows, we're actually combining the LLMs with tool calling. And this is now becoming the default. And this allows LLMs to overcome their inherent limitations like not being exact or not being up to date, as you saw with the ClickHouse example by Dimitri. We're seeing many projects in this, also many frameworks, so semantic kernel, PyData, LangChain, and of course MCP. And we're also now moving to autonomous agents. So at ML6, we are now getting some projects with autonomous agents, and it's slowly making its way in production. So what is an autonomous agent? We call it autonomous when it's an LLM, which is connected to tools, but which also has really the reasoning abilities to make its own plan and then decide I want to use these tools, and maybe I want to even call these different agents. So we have some projects at ML6 that are doing that. Nothing productionized yet, but some interesting use cases are travel planners or collaborative content creators where you have a team like writers, video creators, marketeers. And we actually have a demo internally, which is the virtual tumor board, which we think is really cool. So I would like to show this virtual tumor board. The idea is that at hospitals, you have the surgeons and the doctors discussing certain cases. And these doctors have their own specialities and are good in their own fields, and they bring their knowledge to the table in those conversations. So we try to mimic this in the virtual tumor board. Also have a little video about this, which will be very hard to see for the people in the back, but I'm still gonna try. Hopefully I have sound also. No sound. All right. No. All right, no sound. Doesn't matter. So what we're seeing is, we even have no screen anymore. Okay. Let me see if I can fix this. So going from no sound to no screen is a real bummer. All right. Yes. So yes, we have the virtual tumor board, and it's connecting the different LLMs. So these are actually agents with their own ability to do tool calling. So for instance, you have one that's focused on genetics, one that's focused on clinical trials, or one that's focused on more immunotherapy and that kind of stuff. One is connected to the database, so relevant research papers about some experimental clinical trials, and maybe another one is just connected to the actual patient documents, which will be interesting. We can then have this system actually mimic the conversation. So here at the top we see the description. So a 9-year-old patient diagnosed with BCP-AL. So I don't know anything about the medical field, but it sounds bad. So it should be discussed. And here we see that the agents are doing tool calling and bringing their own expertise to the table. So here you can also see it gives the references, and it's based on real clinical trials and real papers. So I think this kind of demonstrates just a basic RAG workflow, but that combined with like an autonomous agent, more multi-agent system. Some learnings from this we had. Some real challenges we had when developing this system was that it was very hard to evaluate this system. So when evaluating the system, of course, you often get very different outcomes. It's very hard to get the same outcome. And then if you get relatively the same outcome, it's still hard to decide whether you're evaluating a single agent, whether this agent is doing its task properly, or actually evaluating the whole system, which will make the challenge of evaluating even harder. These challenges are also caused by a lack of explainability, why they are saying stuff, and also the lack of repeatability. Another challenge that we had was the state management of agents. So I think in the Cloudflare talk, we also had the NCPs that now had the states attached to it. That would be super valuable in this situation. So basically, the challenges are the same with normal LLMs, which might have tools connected to them, but then bigger. But then it becomes even harder, because now we're moving to true multi-agent systems. And what are we seeing as truly multi-agent systems? So this can be a network of autonomous agents working together. And these autonomous agents are trained to communicate and coordinate. And they don't have a predefined orchestration. So in the previous example, we saw that we were really calling the different fields in order. They were not yet fully responding to each other, and there was an orchestrator. But if we want to move to a multi-agent, true multi-agent system, we need them to also be able to make decisions independently. So what if we want these agents to be publicly available in an undefined hierarchy? Well, this is where the A2A, Agent2Agent protocol comes in. So the Agent2Agent protocol has been launched by Google, I think about 1 or 2 months ago, and it allows agent-to-agent communication over HTTP. Well, this sounds pretty familiar. Sounds a lot like the MCP, but where's the difference? We'll get into this later. But here, they really let agents communicate with some standards. So it's secure by default. It builds on the existing standards, supports long-running tasks. We'll also get into that later. And it supports multimodality. So the agents should be able to communicate in audio, video, images, and of course, text. And now I would like to envision this virtual tumor board, but then with the agent-to-agent framework. So we had these different agents. So for instance, the cell therapy agent or the genetic agent. We can also imagine that currently they might be in the same system, controlled by a single framework. But what if these would be controlled by the different departments within the hospital, or even different hospitals altogether? Or maybe just different companies. And this would allow the agents to really be restricted and operate on their own knowledge bases. It's also easier to maintain the state. So you can really have the system on an isolated server running and get requests in there. So the state is fully isolated. And they can be specifically trained to excel in their own field. So it's easier than with NCP to really call a different LLM. So it can, for instance, be fine-tuned on more the data for the immune agent. So how does this work? I will show a little bit of code, extra code in a bit, and I'm pretty sure people in the back will also won't be able to see this, but it works with first the agent discovery. So you program some agent cards. So this would be the reimbursement agent with a description. So this agent handles the reimbursement process for the employees. And this gets broadcast to actually the agent you are calling. So this is the agent card. This would, for instance, be provided via the well-known URI. So that's a well-known and agent.json. You could also do this in just more curated registries, so inside the company, or really privately connect to different agents. They did really learn from MCP to move towards the enterprise-ready features directly out of the box. So it works over TLS, authentication according to modern standards, so no payload identity, common authentication methods, OAuth, all that stuff. And it uses, you can simply use like existing frameworks for tracing, observability, and monitoring due to the reliance on the standard HTTP protocol. And then it is also designed to handle tasks that do not immediately complete. I think we're all experiencing right now that in the beginning, the streaming was slow, but now if you're even doing tool calling, those tools might go wrong. It might get in a loop for a little bit until it figured it out. Agents can take a long time. And the system needs to be designed for this. So they implemented streaming with server sent events for this, for incremental results. So that's really the streaming implemented. And for very long running tasks, they implemented push notifications. And they even indicate that this will allow a connection to go, well, it can be disconnected, but a task to go for days even. And they put this in the docs. MCP love A2A. If you read something about the Agent2Agent protocol, they often quickly start, so what's the difference with MCP? And then they say, MCP love A2A. So the main difference is that MCP is really for doing communication with the tools themselves. So there is no extra LLM there. It's just doing the tool calling. So for instance, to a vector database. But Agent2Agent is really for communication between agents themselves. So this is what Google also markets it to be. But we have to stay critical. So it's also interesting to say, all right, but what if one of those MCP calls is actually just a call to a different agent? Doesn't that just replace the Agent2Agent protocol? And then they also list their partners in this venture, and Anthropic isn't in there. So we're holding tight. Maybe Anthropic is coming with something. So yeah, I took this screenshot from the Meetup. You've seen the MCP hype. Well, you might have seen some A2A type, and now let's get some real understanding and see some real-world examples. I quickly spun up the example of Google's A2A to see if I could get it to work. I will zoom in a lot. So we can run this, and this would be the main agent, and this agent is kind of wrapped in a chat UI. We can run the reimbursement agent, which we just talked about. It's also interesting that in this demo, they added the different packages. So they added, for instance, LangChain. They added the Google Development Kit, the Agent Development Kit. They also added semantic kernel. So if you're looking into how this can work together with the framework that you're currently using, have a look at this demo. We can run the reimbursement agent here. Also starts up as at a separate agent. And we can run the lang graph, which starts up as a separate server also. So let's check it out. So yes, let's get this full screen. This is what the UI of the multi-billion-dollar company Google looks like. And now we can actually add the agents here. We could just do it via the addresses. So I think it will be localhost. This one, oh, can't connect, so have a look which one it is. Yes. Oh. Have a read. And this would be then the card that we just talked about. So that's the agent card. With the description and also whether it supports the streaming, whether it supports the notifications. And you can connect. And we can also connect to the currency agent, which is there to translate certain currencies. Here you also see the card for this agent. And then you would be able to chat with that. No. So which agents are you connected to? And then let's hope this works. And it gives the agents it's connected to. Can you give me the exchange from 20 euros to dollars? See if this works. And I think this is a very basic demo, and that's also, I think, what's to be expected. So we're doing things that we can already do, but then in the backend, we are really showing, we are really doing it differently. So we're using the service. All right, so we're using the exchange agent here, and we're using the reimbursement agent here. And we can also see these, getting in, coming in the terminal. So that's a small demo, just to show that it's easy to set up, and also maybe to give you some feel so how it would be for the agent to actually get these cards themselves and play around with it. So maybe time for some judgment. So the goods, so they have the support for the long time completeness, completing of certain models. They are also using the JSON RPC format, which is also very easy to work with. They also are introducing the agent marketplace. Maybe also sounds familiar for people that have looked at the MCP registry. The agent card is also pretty easy to work with, also very familiar when you look at other frameworks. A big advantage is that you now can use the right size models, which is also interesting, so you can maybe use lower cost models for certain tasks. It's modality agnostic, so you can use other types. And authentication is built in. So it's also learning from MCP's mistakes there, that first there was no real security in MCP. The bad, so I think they're making a really good start. Looking at the code, I think they are still really immature, as the demo code is now already pretty different from the Python package that you can actually install. So they're really marketing themselves as this being an enterprise solution, but the code really isn't there yet to really use it for enterprise. Also, if I would be asking myself the question, is this really the framework that is solving the problems I have right now? And it's not. So if we're looking at the evaluation or the state management might be solved a little bit, but to be fair, it solves it the same as another framework might do. Explainability and repeatability is also not really solved. So it's there and it's really interesting to use. But it doesn't really solve the problems we are experiencing right now with building multi-agent systems. So is A2A, some opinions maybe, is A2A more secure than MCP? I think so. I think it's definitely now set up better from the ground up. Though I really think MCP with the recent changes and also changes in the future can really get there. Has Google just invented a more complex and less deterministic REST API? I also saw this in the YouTube comments somewhere. I liked it a little bit. Because I think the protocol that they propose is quite easy to implement yourself. But to be fair, they implemented it. It's easy to use. We're looking for a standard and we want mass adoption. So if they're doing that, then it's good. And if we have MCP, we don't need A2A. Also a maybe, because MCP, if it's just connected to an agent, it can kind of do the same. Though MCP really doesn't have the streaming support yet, for as far as I know, and also doesn't have like the long-running completeness support.
Turn it around and say, if we had A2A, do we really need MCP?
Yeah, I definitely think you can turn this around. Though that would mean that we would use another framework for the agents themselves and running on their local server to do the tool calling, which I think there's a lot of frameworks. So it really depends on what do you want to be hosting separately. And it's too early for A2A a little bit. It's not solving the problems we have right now, but it's a very nice idea. So I'm very curious whether in a year we'll be talking about A2A or MCP, or maybe a third framework even. So that was my talk, ready for the Q&A. I'm Titus, data engineer at ML6. Maybe I haven't told you yet. And I just want to say, if you think this is cool, if you think it's really cool, then we're hiring at ML6, so you're also welcome to talk.